What's up, it's Paul, and I'm going to show you today how to divide rational expressions. I've already done a video on multiplying rational expressions, so I might repeat myself in a couple cases here. So with dividing, and since we have rational expressions are often expressed as fractions, remember that dividing by a fraction means that you multiply by its reciprocal. So in this first example, I have 5x squared minus 20 divided by 25x squared divided by, I should say over instead, divided by x squared plus 6x plus 8 over x squared plus 10x plus 24. So again, the first fraction is going to stay the same, but since I'm dividing by the second fraction, I'm actually going to be multiplying by its reciprocal. So it's going to be times x squared plus 10x plus 24 divided by x squared plus 6x plus 8. And like with multiplying rational expressions, I'm going to factor everything first before I multiply. So 5 times x squared minus 4 divided by 25x squared. That really can't get reduced much yet. And then x squared plus 10x plus 24. Since it's a quadratic trinomial, that factors into x plus 6 and x plus 4. And x squared plus 6x plus 8 is x plus 4 and x plus 2. Now x squared minus 4, since that's a difference of two squares, we have 5 times x plus 2x minus 2 over 25x squared times x plus 6, x plus 4 divided by x plus 4, x plus 2. Now I will say that we can multiply them, combine the numerators and denominators. We'd basically be rewriting them as one fraction, or you can reduce right from here, and then we'll just multiply whatever's left. So generally I like to multiply everything first, but in these cases it's not a bad idea to reduce off some of our factors because there's so many of them and they're so long to write. So I know the x plus 2's will reduce off. I know the x plus 4's will reduce off. And I also know that 5 reduces to 1 and goes into 25 5 times. So now that I've done that, multiply whatever's left. The numerator is x minus 2 times x plus 6 divided by 5x squared. So that's what you do if you have to divide by a rational fraction, a rational expression as a fraction. But what happens in this case where I have something divided by a fraction and then times another fraction? Who do you flip over? Well, you only flip over the fraction that's directly after the division sign. So for example, I'm going to factor as I go just to make this go by a little quicker. So x squared plus x minus 30, that's going to factor into x minus 5, x plus 6. And then since we're dividing by x squared minus 2x minus 15 over x squared plus 7x plus 12, we're actually going to reciprocate that fraction, and that becomes times x squared plus 7x plus 12 over x squared minus 2x minus 15. And since I'm multiplying by this last fraction, I leave it alone. You only flip over or reciprocate those fractions that are directly after the division sign. And I didn't factor those as I went, as I said I would. So I'll do it now. So x squared plus 7x plus 12 is x plus 3, x plus 4. And x squared minus 2x minus 15 is x minus 5, x plus 3. And now we can either multiply everything together, and I think because one of them doesn't have a denominator, that might not be a bad idea in this case. So this combines to be going to be a little lazy here. X minus 5x plus 6 times x plus 3, x plus 4 times x minus 5 all over our denominators, which are x minus 5, x plus 3, and x plus 6. I'll give that parentheses as well. And now we just reduce off who we can. So the x minus 5's reduce off, the x plus 6's reduce off, the x plus 3's reduce off. So everything reduces off the denominator, so there's a 1 left over. And our final answer is x plus 4 and x minus 5. I almost ran out of room there. And you would leave it like that. You wouldn't multiply them through because the directions for this would be factors. So they're split up in their factors. If you like this video and you found it helpful, please like it below, comment on any subject you'd like me to cover in the future, and subscribe to my channel. Thanks for watching.